Okay, so welcome to the Unlocking Innovation, fourth day, as I said, data-driven maintenance. Oh, sorry, I've got to switch off. We have a motion-controlled light sensor, and I have to wave a scarf to just switch it on sometimes because I haven't moved for 20 minutes. So let's just go to the next slide. Our Unlocking Innovation program is supported by Network Rail and UK Rail Research and Innovation Network. So we're very thankful to our partners. We could not do these events without their support, and also very thank you much to you who attend the events and our speakers. Before we'll start the session, we are conducting a bit of a data collection, and my colleague Sam will drop in a link in the chat. If you do have a few minutes, please go to the link and fill in a form. We really want to see what you think and hear your get your comments. So please do that. So this is the fourth session. All of the presentations have been recorded, same as this one, and we will publish them on our YouTube channel. We have a YouTube channel where you can find all of our Unlocking Innovation recordings from previous sessions as well. So please do check that out. We will share the recordings next week. The link will be included in the Tech Talk, and we'll send a special Tech Talk as our members only communication, but we'll send an email to all of the innovation communities as well. So today we have the list of speakers here, and we have a very tight schedule, so I will not talk for too much longer. Each Unlocking Innovation, we try and look at different sectors and learn from their best practices. So yesterday, if you attended the sessions, you heard from submarine industry, and today we'll now go to Chris and see how the gas turbine data-driven maintenance is happening. So Chris, if you could just turn your camera on, I will stop sharing my screen so you can start share yours.
Perfect. Thanks a lot, Milda. So yeah, my name's Chris from Frazer Nash, as Milda explained there. For those who are in this morning session, it's kind of a double header because I finished this morning and I'm starting this afternoon. But I'm going to give you a totally different perspective this afternoon. So what I'm going to talk to you about now is condition-based lifing for gas turbines. I'm going to take you on a bit of a journey of kind of gas turbines in general, and tell you a little bit about why it's important and the savings that we found some of our customers make in gas turbine space. Before I launch the slides, a bit of a background of context on Frazer Nash and the kind of stuff I'm going to talk about. We're an engineering consultancy of just north of 900 people, 11 UK offices and 4 out in Australia. About half our business is defence based, about 25% is energy based, and that's what quite a lot of the stuff I'm going to talk about today comes from. And the other 25% is what we call transport and industry, which is where our rail business sits. So we've got quite a nice perspective of taking a few different viewpoints across the market sectors, and that's what I want to share some experiences, etc., with you today. So I will share my screen, and all being well, that will come up. Let me just get you back again. There we go. Right, so what am I going to talk about? I'm going to talk about industrial gas turbines. As I said, it's going to be about 20 minutes long, and I hope is going to provide an interesting perspective. So what problem are we trying to answer? Well, industrial gas turbines. So we're not thinking about things on the side of aeroplanes in this context. When we think about gas turbines, we're thinking about things the size of your house, big industrial complex machines. And we have a particular client of ours who I'm not going to talk about specifically today due to confidentiality reasons, but they own 15,000 of these units around the world. Big, heavy, complex pieces of machinery. And a number of years ago, they made the strategic decision that they wanted to change their operating model from selling a unit, so selling a gas turbine, towards selling the availability of that unit. And in order to enable all that, it's very important that they understand the maintenance regimes, because by selling it on an availability basis, you are inherently then far, far more interested than the routine maintenance payback you often get when you sell assets. So it's a journey they've been going on for a few years, and Frazer Nash have done various bits and pieces that I'm going to talk to you about today. So where did all this start? So I'm going to talk about as I just said, this is not about civil aerospace gas turbines. I'm actually going to use that as an example to start with. So when we think about condition-based lifing and condition-based maintenance, if we look at Rolls-Royce as a case study and their power by the hour approach, it's not new stuff, and it's been around in industries and sectors for decades and decades. The first power by the hour kind of market approach and selling from Rolls-Royce was way back in 1962. So we're talking, what, 59, 60 years ago there, where they took a Viper engine and sold it on an availability basis. They retransformed their business in about 2002 when they launched the Complete Care package, which was the first time that the kind of data and instrumentation was able to play a really key role in condition-based life estimation and thus condition-based maintenance. So you look at a modern Rolls-Royce jet engine these days, and one of these two big lumps on the wings here, and it's got hundreds and thousands of sensors across it. It's a program that they've been on for a number of years, and they've got real-time data being transmitted from all their engines around the world back to a monitoring system centrally, does some onboard processing and some offboard processing that allows them to have the confidence that they understand what their assets are doing, and thus have great confidence in when they need to be maintained and interventions need to take place. But regardless of the asset in question, the fundamental approach here starts with the asset. So it could be a railway locomotive, it could be a box wagon being towed behind a freight train, it could be a civil aerospace engine, it could be an industrial gas turbine. The next thing that we tend to see is sensors. And I'm going to talk in a minute about the need for sensors and the need for real-time data, and actually the differences between data and engineering and physics-led approaches and the relative cost benefits of both. You've got real-time data and you're doing stuff with it, but actually we need some models and predictions. And for anyone in this morning's session, me and quite a few others talk quite a lot about machine learning. It came up, I think, in nearly all the talks. And what we're talking about with predictions here in that kind of real-time maintenance space, and especially when applied to the gas turbine example I'm going through, is less about analytics and more about physics. So this is about predictive models that take operational history and real-time information and use it to predict the physics of what's going to happen to an asset. So it's not about necessarily just lots of number crunching and data. This is about ground up physics and engineering based predictions of what's going to happen. And when we've got those physics-based engineering predictions of what's going to happen using real-time data, that's when we can start to drive in that maintenance at the right time, at the right place, the condition-based maintenance. We can use the models to understand the life of assets and their components, and we can then start to revolutionize how we actually go about doing that stuff. All of that stuff doesn't come for free, and this is often the bit that puts people off from that first step on the ladder of condition-based maintenance. You either need some kind of very forward-focused strategic direction board down to make the investments, or you start small and do some sensible stuff. And hopefully I'm going to explain over the next few slides about how the starting small can really benefit people. But fundamentally, you need some information, you need some data, and you need to spend some time doing the engineering understanding of what's going on. So digitization is key, it's crucial, it's critical, whatever word you want to insert there. Data and information about what an asset is doing is very important. But uncertainty about that data is also an allowable concept. We don't need precise, accurate estimations of everything all the time, and I'm going to cover that in a couple of slides' time. So we see lots of digitalization. COVID's escalated the kind of digitization journey of quite a few organizations where everyone's been forced into the 21st century. We've got quite a few customers historically who haven't been in that kind of space, but now are, because the hand has been forced. But when we think about assets and data for digitization, there's two schools of thought here. The first one, and probably the most common, is the kind of big data approach. This is putting instrumentation on lots and lots of things. It's having lots of instruments recording lots of things all at once, getting readout of GPS location 20 times a second and storing that. But it results in big data, lots and lots of big data. What does big data mean? Big data means big computers. We've got to store this stuff somewhere, whether it's in the cloud, whether it's on localized service, whether we do some edge processing on device and send it somewhere. But fundamentally, we need the investment in the big computers. Big computers and lots of data, very good for some of the topics we covered this morning around machine learning, understanding correlations, using neural networks to predict behaviors and understand what's happened in the past. And we can deduce quite a lot of good meaning from that. And we can start to hypothesize about cause and effect of what's causing various maintenance things to occur. And ultimately, we can make better decisions. So as a process, a data-led approach does lead us to the better decisions space. However, the slight downside of that is you've got those big computers on that second box down there. It often requires quite a lot of upfront investment, and the appetite can be quite unappealing from an investment perspective when your return on investment, when you're actually doing maintenance in a different way, and maybe commercially you're operating your business in a different way, can take quite a lot of time. So more common approach, and the approach that we tend to take with industry, and the approach that's definitely at the forefront of the gas turbine example, is an approach led by understanding. So we're trying to get away from lots and lots of data, and we're trying to use engineering and physics-based judgments of what a system is. So if we take a rail locomotive, there's lots of different bits and pieces that make that system up. We don't need to know about all of them necessarily to understand what condition-based maintenance and condition-based life estimation means. What we need to do is understand which bits are critical. So which bits impact life, which bits impact maintenance regimes. And when we've understood what they are, we need to go away and we need to capture some data about those. So we can instrument up the bits we care about and get away from our lots and lots of data 20 times a second into maybe data once every half hour about the particular fluid level of a system or particular vibrations through a certain part of our locomotive, of our gas turbine. But we can monitor that. We can get an appropriate amount of data based on the engineering and physics that's driving our approach here. When we've got that, we can build simple, or we can build complicated models to start with. So maybe kind of in the case of gas turbines here, we might build complicated fluid models of hot gas paths through a gas turbine using CFD, using structural analysis. But crucially, if we're going to do condition-based lifing and estimation in real time, we need to simplify that. So let's start with the complex. Let's use our measured data to simplify the models to a reduced order, validate them against the real world data, and effectively give ourselves a way of estimating what the life looks like, what those performance limits are. And that's at the heart of the kind of understanding-led approach. We get to the same kind of endpoint in that we're making better decisions still, but actually the route that we've got to making those better decisions is far, far more simplistic in terms of our overall initial investment, but requires a bit more time doing the kind of engineering horsepower of the system understanding in how we're collating that. There's a few buzzwords that apply to various points of this life cycle. So the point at which we've got models taking real world data and using them to derive meaning of what's going to happen next, predicting the future. That's where I'd put digital twin, but everyone on the call has probably got a different definition of what a digital twin is, a digital asset, but that blending real world data with predicting the future based on physics is how I think about a digital twin. And we've got this greater trust in the end. Why do we do it like that? Well, fundamentally, we spent a bit more money in the kind of understanding middle ground and maybe up front, but the amount of hardware and data storage and costs that we've had to procure as part of it is orders of magnitude lower. So our return on investment is much, much quicker. And actually we can get something up and running quite readily and quite quickly in doing our condition-based lifing. So how does that work for a gas turbine? What does that actually look like? What's the process when we do condition-based monitoring and crucially condition-based life assessment? Well, fundamentally, one important thing to think about here is the kind of story we're talking about. There's 15,000 separate things the size of your house. Like we're not talking about small scale equipment in this particular example, but every asset is different, and that's something we need to recognize. We're not trying to generalize that 58 of these things are all operating exactly the same way. We need to be cognizant and understand that we've got lots of different things, and we need to understand each one in the right way to understand what its maintenance activities are about. But fundamentally, it starts with the asset, gas turbine, railway carriage, whatever it might be. You've got an asset. We need to do some data processing. So in the case of the example we're talking about today, we've got various trips, various cycles that turbines go through. We need to understand how to acquire the right information at the right times. It's quite noisy data, quite a lot of vibration within some of the data that's measured that we often need to filter out. So some signal processing is required. And then we need to analyze that data to chop it up into the bits that we want to feed into our predictive life models. So we've got some data processing stuff going on. In the case of a gas turbine, the bits that really cause us pain there, these things operate at kind of internal temperatures of thousands of degrees, very, very very significant creep and fatigue problems occur in a very complex piece of engineering design. But fundamentally, we need to be able to model that in a way that we can take our data in real time and feed it into our reduced order models. So our models and component and stress and temperatures of what's going on within this particular example, we need to figure out what those models look like and build them. When we built those models, we can then use them as the predictive engine to give us our life estimations. So this is where we've done complex models, we've simplified them, we've validated them using operational data, and we're now in the world of doing real-time estimates of life. So as I said before, the key failure mechanisms in this particular example being creep and fatigue, and indeed creep fatigue is a slightly different effect. But we have built the models to do the life prediction. And every time someone changes what they're doing with their asset on the left-hand side, so they may be using it a bit harder, ramping up, we've got a particular need for energy in this particular part of the world today, so we've ramped up how much we're using our gas turbine. That gets fed through the data into the models, into the life assessments, and in real time, as an owner of this particular asset who is now leasing it on an availability basis, we get the information we need to take action in the most appropriate way. And that might be saying, well, saying to the end user, we notice you've increased your usage of asset X. We now need to come in 6 weeks earlier than we were otherwise going to, because we can see the life of particular components within that mean that we need to intervene to make sure your asset continues to operate as you'd like it to and as we want it to. But it's that positive intervention that feedback loop induces that gives everyone a better understanding of what's going on, and the operator can say, well, actually, you can't come in 6 weeks, we've got some critical stuff going on. I'm going to swap out this asset for another asset in how I'm doing stuff this week to make sure that their production line works well. And it's that intelligence that we're adding in the condition-based maintenance approach. So why are we going to do it? Why are we doing this stuff? Well, fundamentally, it's about damage. What we're talking about with condition-based maintenance, condition-based lifing, is we're causing detrimental effect to an asset, whatever it might be, gas turbine, railway carriages, etc. But what are we causing that damage relative to? Well, traditional maintenance cycles are based on number of hours, number of years, whatever it might be, between maintenance periods. And the way we get to those periods of, let's say, 20,000 hours of operation is that we look at what it was designed to do, we look at how that design point is likely to be seen in service, and we make a plan to maintain it around that. But it's conservative. It has to be conservative by its nature. What we do when we're looking at actual usage is you start to see things are less damaging. Nobody's really using an asset as hard and as fast and as long as they are designed to be used. And that presents an opportunity for us to do more with our maintenance windows. So putting that graphically, don't like putting graphs in presentations, but I think this helps illustrate the point nicely. If we're designing something on the far right of the graph we see here, and this is the kind of 99th design point, the limit load times whatever factor has been applied structurally to our, let's say, rail carriage here, what we actually see in operation might be something that's operating at completely the other end of the damage curve. And we're not operating it in a way that's causing anywhere near as much damage as it was designed to have. And what that gives us is an opportunity. It gives us an opportunity with uncertainty to understand what we need to do to that asset to maximize its usage. And condition-based maintenance and lifing is about quantitatively finding out what that opportunity looks like, how big is that bound we see there on the graph, and crucially, using the predictive lifing models, exactly what we need to do now to make sure that we never tip ourselves over the damage point where we're going to be causing significant damage and things fail. And that for me is what CBM is all about. So final couple of slides just to wrap up to show you what this looks like. So this is some example data from a collection of industrial gas turbines. In the particular example I'm talking through, each of the little red dots, you might not be able to see, but each of these little red dots is a particular asset. So I said before, we've got about 15,000 of them here. We've got, what, 20 or so shown on this screen. They've all been designed to run at the red line at the top here. They've all been designed against this design condition. And it's fairly apparent to anyone looking at that none of them on that particular view are operating at the design condition. So why are we thinking about maintaining our fleet in the same way? Why are we going in after 20,000 hours to maintain an asset that's been operating at 900 degrees Fahrenheit-ish in this example, when it was designed to operate at 14? And that's where the opportunity lies. It's about using and understanding lifing of, in this particular case, the hot gas path through the middle of an industrial gas turbine to allow us to exploit the maintenance windows to best effect. And it's obvious when you see it like that, I need to maintain this one probably less often than I would maintain this one. This is just one temperature in what is quite a complicated piece of machinery. So it's blending all of those different design points based again on our engineering and physics-based understanding of what's happening in the process to allow us to maximize the exploitation through life and thus basically essentially change our maintenance windows. So what's the end result? So this organization have been on this journey. They're at the other end of it. They now sell availability-based metrics. Some of the pictures on the right-hand side there are some of the interfaces to the system. As I said, the customers really nameless here, but they've got sensor data being recorded every hour and being sent back. It's feeding into real-time damage models so that they get the ability in a dashboard view for all of their assets to be able to see when they need to maintain things, and crucially, when things change, what they then need to do about it. What are the benefits? So reduced cost of maintenance. For them, their spare holdings have reduced by 70% because you've got, and that is massive when you think about the number of units they're responsible for globally. They know when things are going to fail, they can predict when things are going to fail, and they can intervene before that point. So why have warehouses full of spare parts? You don't need to do it. Cost savings here measured in the tens of millions of pounds because you haven't got as many spares and you're not doing as much reactive maintenance, and fundamentally you're doing less maintenance, full stop. And that's the kind of end result. They've been on this journey, they've invested in the process, and they understand the damage mechanisms. So that's all I want to share with you today. Roughly just shy of 20 minutes there, I think. Quite happy to take any questions. I'll be around in the Q&A later, but if anyone's got any questions that we want to go into now, I'm not sure how much time we've got, Milda, but more than happy.
Oh, we've run out of time for your slot, but
no problem.
As Chris mentioned, we will have an open networking discussion after all of the presentation. We'll keep the call open until 5 o'clock. You can pop any questions via chat to Chris, but also Chris, you mentioned you'll stay on and then you can interact with the attendees. So thank you very much.
No problem at all.
Now, if we can move on to our next speakers, Sarah and Hamssa from Network Rail Research and Development Team, and they will talk about the accelerated innovation process. So over to you, ladies.
Good afternoon. So I'm Sarah Mulcahy, and I'm a project manager, or in Agile terms, a Scrum Master in Accelerated Innovation Team. We're part of the research and development portfolio that sits within the technical authority at Network Rail. And my colleague Hamssa Qureshi is also a project manager within the team. Over to you, Hamssa.
Hello. So as Sarah mentioned, we're here to talk about the accelerated innovation process and how this has been used to accelerate some of the data-driven maintenance projects that we're running. Accelerated innovation is a process that embeds an agile methodology within an R&D project delivery environment. So the process aims to accelerate the delivery of technology solutions and accelerate the benefits to our routes and regions. So it uses a user-centered design and it encourages collaboration and focuses on gaining early feedback from end users and trialing data-driven maintenance solutions earlier on. So this actually means that project teams have been able to not only focus on getting data, but also maximising the benefits of the data and making sure that the data is available at the right time in order to make the right decisions. So in this presentation, we're going to be covering the key learnings of this trialled and tested approach that has been developed. Firstly, I'm going to run through key concepts and benefits of Agile, and then Sarah's going to go on to giving some examples of the AI process and how this has enabled acceleration of value with some of our data-driven maintenance projects. So the key concepts in Agile, we value certain elements over others. This is when it comes to project delivery. So it isn't saying that we don't value the items in red, but it just means that we value the items in green more. So for example, we value individuals and interactions over processes and tools. So again, it comes back to the point that I made earlier on collaboration and early feedback from end users. We really encourage working closely in these teams so that we're able to recognise what the challenge is and how to address it earlier on. We value working solutions over comprehensive documentation. So again, creating what we call an MVP, which is a minimal viable product, where we're addressing a challenge directly and developing a proof of concept. We're encouraging. We then encourage early user feedback and ensure that we've got a fit for purpose solution. Also, within Agile, what we do is we encourage change effectively. So we recognise that that much earlier on, we don't actually know that much about the solution. We don't know that much about the project, but actually when we start the project, certain things become apparent. We might know more about the data that's available, more about the technology that's available. And with that, we encourage end users they're able to change the scope. There's no shame in that at all. So like I said, the concepts here are around limiting the constraints around adapting around adapting to gaining that final solution. So this slide just shows some charts to show the difference between an agile methodology and a traditional methodology. So it covers 4 key concepts: visibility, value, adaptability, and risk. So with visibility, like we said, if we've got a POC, a proof of concept that's being developed earlier on that addresses a key challenge of the end user, we normally work in sprints, which is normally around 2 weeks. So we develop within these 2-week sprints, and we're constantly demonstrating to the end user. So you can see that wiggly line there shows that actually at the end of every sprint, we demo to the end user and they're able to see where we're up to, and they're able to build in functionality into that. Whereas with the traditional method, you can see that curve there. That's normally the big bang method, where actually the end user might not see the end product to the full extent of it until the very end. It might be that they don't see the full product because there might be different elements and they don't see the full thing until the very end. So in terms of value as well, with the traditional method, with Agile, your value starts to accelerate much earlier on, and that's because you've developed your solution much earlier on, and then you're just building in functionality. So actually your value is realized a lot earlier on, whereas again with your traditional method, you don't start to see the value until the very end of the project. In terms of adaptability as well, so that comes back to the point that I was making around change. So with the traditional method, actually, as you go along, it's more and more difficult to make those changes because you're more and more deeper into the project, and it's harder to change the scope at that point. Whereas again, with Agile, change is not discouraged within Agile, so that can be changed throughout. And then risk is significantly reduced much earlier on with Agile, and that is because really links back to all the other elements. If the product is very much visible to the end user, and if they're able to make changes throughout, it's very unlikely that they're going to get to the end of the project and be shocked by what they see or still need anything changed. It's very unlikely that it's going to be unfit for purpose. Next slide, please. So this just covers the benefits of Agile, benefits of being of agility, really, and this all comes back to the previous points that I've made. So faster time to solution. Again, you've got a working solution much earlier on. You're just building in functionality. So that just means it means that your end users have got a solution much faster. They're happy with the fact that you've addressed their challenge much earlier on. Comes back to the same thing with return on investment as well, is realised much faster because that solution is delivered much earlier. Your you're building, you know that you're building the right solutions because you've been incorporating the changes throughout, and any new ideas and any new discoveries throughout. You're gaining user feedback constantly. And obviously, with all of that, you're a lot more confident that you've got a better quality product, just because you're starting with your basics and you're building in quality and functionality as you go along.
Sarah, you're muted.
Oh.
Can you hear me now?
Yeah.
Perfect. Excellent. So within the Accelerated Innovation team for data-driven maintenance projects, we have 4 key areas that we've looked at in terms of benefit. So we have the smart investment, the accelerated pace, the potential benefits, and engaged stakeholders. So in terms of this, for me, the engaged stakeholders is quite key. As you'll see, it fits over all 4 of them. And we have the Agile process templates, governance and training, and the Agile procurement strategies. We've worked with our contracts and procurement teams, and also new models, which has helped mobilise some of our projects. One specifically in that, as an example, is our ESR TSR, which is all around emergency speed restrictions and temporary speed restrictions. This has enabled us to use existing data, so we're plotting them correctly in the right locations, rather than giving people its 15 chain links from one position. In terms of smart investment, we had a project called FOAS, which is fibre optic acoustic sensing, and we realised quite early on that the technology doesn't exist to look at using the wheel flat information that we could get from the sensors in order to improve asset maintenance. Because of this, it meant that we could release 57% of the budget early, which then could be reprofiled across the portfolio. And as you can see, this then meant that we could do the ESR TSR project, which again, we only utilised 10% of the project to actually test the initial hypothesis. The remaining budget we were then able to use to achieve a greater minimum viable product, or MVP, as you may know. In terms of delivering a minimum viable product, we have been able to deliver this at 30% lower cost than similar previous projects across the R&D programme. One of these examples is our possession management. So within our possession management projects, this then led to having a single source of truth and also reducing time on track. So as you can imagine, the lower cost that we've managed to produce, because we've done iterative changes throughout using Agile, rather than listing everything at the start that we thought we needed, implementing a contract with all that listing. It was an iterative approach, and we focused on what was essential, and we delivered that minimum viable product. In terms of accelerating pace, which is where Agile gets its name, and the team Accelerated Innovation, we've managed to mobilise and procure and deliver projects quicker. Again, this comparison is against similar R&D projects in the past. So we've been 65% quicker on the fibre optic one. This meant that we could engage with the market sooner. We could use Agile forms of contracts rather than being tied to a fixed scope contract. We delivered 75% quicker on a similar project on possession management that was previously looked at within the route. And the key for us is engaging with the customer. For us, this is mainly the route and region, and we engage with them a lot earlier on. So we're talking 83% earlier. As I'm sure on a lot of projects, you find that a lot of the discussions happen without the end user or the key stakeholder involved. And for us, the route engagement is key. They are our key stakeholder, and they're generally our end user, and they're the ones that will experience benefit and recognise the efficiencies across the regions. In terms of potential benefits, we've had potential savings of up to 1.7 million in CP6, so we work in control periods. which is a 5-year period, which, as you can imagine, is a significant amount of back office efficiencies. And this has come from our OLE STAT tool, or OLE Static Analysis Toolkit. I know what's OLE STAT. And this basically uses existing data and allows us to analyse and help us with maintenance of the track and using the data that we can collect as the trains run along. In terms of also practical measures, we've reduced or have the potential of reducing near misses by 15% and also improving access to track by 10%. And this is with reference to the possession management tool that we spoke about earlier. By allowing the reduction of people being on track, this will naturally reduce the near misses. We could say the potential of reducing the near misses because not one project is solely reliable to one benefit. In terms of estimating switches and crossing life extension, we reckon that we can get a 25% life increase by introducing a sensing product called Connex that we've trialled recently, and this will help with our predictive maintenance solution rather than looking at a reactive solution. So these are just some of the data-driven maintenance projects that we've had, and these are just some of the efficiencies or benefits that we are looking for and we have already achieved through doing an agile approach. If anybody, I think if we have time for any other questions, or you can get in touch with Hamssa or myself at accelerated-innovation@networkrail.co.uk.
Thank you very much, Sarah and Hamssa. Our speakers are running right to their allotted time slot, so we will move on to the next slot. But please do post your questions in the chat, or if you're staying at the end, please just engage with them. So thank you, Sarah and Hamssa. Now I'm welcoming Luisa Moisio from RSSB, and she will lead a short interactive workshop for us. So Luisa, over to you.
Thank you very much, Milda. So yes, I am Luisa Moisio. I'm heading up the research and development program at RSSB, and I'm here very much with my rail technical strategy hat on, as I've been heavily involved and led the development of the last rail technical strategy that was released in October. Has been very much a cross-industry effort with a lot of input from Network Rail R&D team and beyond. Lots of input from Ukraine as well, both commercial partners and academics, and with a fantastic support from organizations like RIA, who are always very much promoting and helping us with keeping the RTS updated, relevant, and growing in richness and details. And this workshop and this session at this Unlocking Innovation event is very much the opportunity to continue the journey on the RTS, because as is well known, once the strategy is released, no matter how hard the work to create it was, it's very much where the big and important work starts of delivering it. And in this case, it is a cross-industry endeavor. So I hope a number of you would have come across it in some shape and form. If not, this is the summary on a page. 5 functional priorities, 3 critical enablers, and all of them together are really important to unleash the innovation and the change that we need to deliver on those 4 outcomes that are vital for railway to continue and have a success future. When it comes to data-driven maintenance, there are quite a lot of references and quite a lot of very relevant points that the RTS touches on. Clearly, the most relevant priority, and the one I will spend 1 minute on in a sec, is reliable and easy to maintain assets. and that is really where things like condition-based maintenance are explicitly touched on and mentioned. But it's not the only important aspect captured in the RTS, the all data-driven piece. And by data-driven, the governance behind data, the contractual implication behind data, and very much also the expertise around data and the new data analysis techniques and capabilities evolving and growing very much daily. And that then also links with one of the enabler, the digitally talented workforce. In a rail technical strategy, we couldn't but recognize the need and the opportunity to very much upskill existing staff that the railway has, and also looking for digital talent. So was mentioning before, most relevant priority, reliable and easy to maintain. This is the introductory slide for that priority, and with the smiley face of our senior sponsor for this priority, Diane Crowder. And then this is the roadmap, because for each priority there is something that looks like this, with high-level goals, a clear rationale for why they are important, the position when we publish it late last year, key stepping stones to reach the 2025 vision, the short-term vision, and the longer-term vision there. The bits that are on this slide framed in red are very much relevant to this Unlocking Innovation event. They recognize remote conditioning monitoring as if you want, the building block on which then data-driven maintenance needs to happen. They also recognize that condition-based inspection and maintenance offers some great opportunities. There are some challenges. And there is a lot of thinking and some experimentation happen, and it is very much about joining the dot, learning quickly, and roll out the most useful approaches and solution fast to gain the benefits. So this is what the RTS says, super high level. And what we're doing now for these priorities and for all the other priorities, as well as the enablers, is to do two things. If you want to, at one end, keep us honest, as the RTS engine room and the people that worked and are still working very much on the RTS, and the wider industry, and trying to capture, are we making progress against these stepping stones? Where are we ahead? Where are we behind? What has maybe hit an obstacle and is not quite progressing? And also what needs unlocking? Because if things are quite nicely moving along, then that's great. That's good to recognize. That is also worth celebrating. And we don't need, in sense of a cross-industry intervention, unblock anything. But where progress are not quite there, then we need to ask ourselves, where is the stepping stone still relevant, and if yes, we can unlock it. So it's a keep honest, keep making progress for the short-term vision, and build and develop further the longer-term vision. On purpose, we were asked to keep these RTS very focused, very tangible on quick delivery, quick benefits realization, the shorter term vision. But we all know that we need to think also longer term. So in that context, what I would like to spend the rest of the time on is to get you to start to share some of the thinking around smart maintenance, data-driven maintenance, condition-based maintenance. And the way I've structured the remaining of the time is to have a 5 minutes each on the as is, where I will soon share a link in the chat, and ask you to share where you are at present in the data-driven journey. If you are a supplier, what have you recently been, what are your products allowing industry to do? What products have you successfully worked with stakeholders to deploy out there on the railway, and share as much of that as you can in the as-is position. We will need to move very swiftly to the to be. So where do you hope to be if you are an operators, if you are an infrastructure manager, if you are a network rail, if you are a supplier again, what are you working towards? What are you developing? What do you hope to have in place in the future, taking a 5-year horizon and a further, and then a discussion and a sharing on, okay, so what are the opportunities? Why do you think you really want to go for it? How important it is for you? What is the opportunity? Whether it is the saving that Chris was mentioning, whether it is something that maybe relates to a reliability issue, and the challenges, and there are many as well, from the approval side of it, the contractual side of it. So it's not going to allow us to will come out in a sec. It's not going to allow us to do to cover all the grounds. It's going to start to scratch the surface, really, but hopefully it will really allow the RTS engine room and team to reflect on your input, and maybe if we all think that is a good idea, get a meteor larger workshop going on this team. And also unblock any some of the challenges that might be in our control. So I've just posted the link in the chat. If you click on it, it should take you to something that, and I will start sharing again now, something that looks like this. And this is then something that is quite intuitively to add on. So what you see over there already populated is if you want the service time-based maintenance that industry still utilizes an awful lot, and for in many cases for very good reason. There is so much space and availability at depot land, for example. It's a good way to be efficient when it comes to resources, and also has a lot of history, and we have been set up as an industry in that way for a long time. At this end of the spectrum is condition based, so very much what Chris has introduced us all to, and for all high value components. And in the middle, I posted an example just to show what your input could look like. So, you know, a brief description: a door monitoring system installed on class whatever to improve fault prediction. And if you can also add name and affiliation, that would be great. You can add just by clicking on this pinky plus button, and you can also move, once you've added it, in up or down, if you want the timeline, so to speak, up and down, to reflect whether where you are is closer to incremental improvement to service and time-based maintenance. And let's not underestimate them, because they are very important. I mean, in the last 15 years, we have seen really good use of that window of opportunity. Again, Chris was describing, great presentation, Chris. It gave me lots of hope for this one, by by recognizing that we were operating at a level that was allow us to push the maintenance cycle of some of those components. So I don't think that we need to be too afraid or worry if where we are is still quite close to service and time-based maintenance, or please put it closer to condition-based maintenance if that is where you
Good
are.
afternoon. My name is Franz Lowe. I want to make an appointment for somebody to.
Okay, so that's. I hope that my explanation has allowed you some time to start to add some comments. I've seen some appearing. So volume of data from modern train is very big. How do we see the wood for the tree? Excellent question. Will fit very much in the challenge. I would encourage, if you can, to try to answer the as is question. So any, based on your role in industry, based on your products line, if you can share where you are in terms of what your products do, how they've been deployed, that would be really, really great. And in 2 minutes, I will move us on to the to be, so where we want to get to. So some really interesting observation that I'm sure we will see again popping up in terms of opportunities and challenges. We have a decision support tool. Okay. I will delete my example now. We don't need it anymore, so we don't get confused. On the decision support tool, if the person that added that comment is happy to be contacted and share a bit more, please leave your affiliation and your name. That would be really, really useful. So let's move on. I will go to the next one. Copy. And put the new link. So you have a new link now in the chat, and it will take you to the next one. The next one looks at the to be. So where do you think the rail industry needs to move to? Where is your work, your products, your investment in innovation? How is it contributing? What can it bring to that to be state? So again, I don't need to kind of go through how to add boxes here as it is as the previous one, with my two icons showing the service time-based maintenance that we are slowly but steadily moving away, or being more clever about, to the condition-based for all high value components at the other end. So again, we'll delete my not relevant box. So condition-based maintenance, prescribed maintenance, first rollout. Okay, so kind of the to be state, to be this confidence in systems that allow this postponement decision. Yeah. A few more are appearing. So interesting again, if you can and want to re-edit your boxes and add your name and affiliation, again, that would be really useful if we feel that it would be good to know a bit more about what you posted. As an example, I was wondering with the first box, the one around the first rollout, whether that contribution is intended to mean that you think is that where we need to aspire to be in 5 years, or whether you think that we can be there, we should be aspiring to be there, and it's possible to be there before. And so that would be for me an obvious, a quite obvious and very interesting question to understand a bit more on that comment. Okay, and great. I can see people have now got the gist of this Padlet, and there are some really interesting comments emerging. Yeah, I think that is on the retrofitment point. Very interesting. I think that there is, in the context of the asset priority, the reliable and easy to use priority, and Paul Gray, that is one of the two leads for that priority, is with us this afternoon. There has been a lot of discussion about retrofitting and application on new build, and I think there is a general agreement that retrofitting is of course more challenging, is unlikely to yield the full results, but I think that there remain the question of a number of our assets have a long lifetime. In many sense, that is good. It puts us in the industry that do already things that other industry are just kind of using buzzword for, like circular economy. So it's good, but this asset legacy can last for a long time or forever. So we will need somehow to tackle that one as well, I suspect, in the 2B, but maybe the 2B for 5 years is not to start there, which is a good, is really a good, interesting thought. Okay, so I will now take you to the final two. I will just a second to copy and paste it in the chat. I will and now go back. Okay, so the last couple of discussion points are about the opportunities and the challenges to bridge the current status, the as is, with the aspiration, the to be. We know that there are some key drivers and benefits that are motivating different parts of industry, its supply chain, OEMs, network rail operators, ROSCOs, to move into a data-driven maintenance. It would be really good if by clicking on the plus sign under this column, you can tell us more about your benefits, the benefits that you think we can get in that move, and you know, any specific, any quantification of it, really great. And on the other column, we have the challenges and the barriers. And I think some of the boxes in the previous Padlet's link were already touching on those. But again, if you want to add your thoughts there on what are the key challenges and barriers, again, if you can share your name and affiliation and share your real life based type experience of wanting to move in that space, but not quite making it, and for whatever reason, that is excellent, because that is really the reflection point that I can bring back to technical leadership group, to the various system interface committees, to the RTS, the Rail Technical Strategy Engine Room, and try to start to unpick them. So on the benefits, we have the availability of assets. We have the cost saving. We have the reliability. It would be really interesting if, based on the work you have done, so likely to be on a specific asset. Or a specific subcomponent of a big asset. You have any data, any information, any specific view on what you have been able to deliver, a bit like what Chris showed us for the gas turbine example. That is really helpful in that kind of persuading senior people, persuading the regulator, and to pay attention, and getting people to invest enough thinking time to make progress. And on the key challenges and barriers, we have, I think, some comments that are still bubbling up and being written. Yeah, again, I'm looking at certain comments. I think that I know where you're going. It would be great if you could share your name and contact, so that we can get in touch to ask you some questions and to explore it with you if you can and want to do so. And again, Chris, I think that on your comment, yeah, I totally agree. And in fact, I think that there is the time lag and the investment, and how you are smart with the investment that you already illustrated very well. There are also the kind of, I think that the periodicity consideration, to the logistic, the practicalities. I was talking recently with Roscoe's around how much they want to push in that space, and their reflections were very much relating to the fact that it needs to be focused on high value components, and possibly even broken down further. There needs to be some understanding that there will still be cycle. So it's almost like, what does condition-based maintenance means on top of maintenance cycles? Yeah, I should have said the newest comments will always appear on top. So if I stay there and I don't get it wrong myself, we will see new. The new comments being provided going up. Yeah, absolutely. The assurance and the safety integrity piece. So as some of you are continuing to write, and I'm really grateful, I will start to wrap up so that Milda will be happy with me. As I said, this was about letting you know that the RTS is not silent on those on data-driven maintenance, and actually more thinking, more work is happening finesse the thinking on what practically needs doing from in a coordinated fashion to speed the process up. Secondly, it was to get some of your practical or on the field's real experience with data-driven maintenance and try to start to capture them. Doing this in 30 minutes only virtual means inevitably that I do the talking and the facilitation, and you help with a lot of good writing, but we don't see each other face to face. We don't have really time to discuss and debate this, even in a virtual fashion. Therefore, I would be interested to know if, and please put it in the chat, if after this quick first attempt at scratching the surface, you would be interested in a longer and more interactive session. The RTS engine room and the reliable and easy to use priority in it is thinking about trying to arrange something like that, and understanding whether you think it would be of sufficient value to you to give us your time would be really a good, provide us with a good basis to take the decision on how to take it to the next level and how to do a bit more thinking. The last thing that, the last couple of things that remain for me to say is that those links, those 3 tablets, I will keep them live and going for give or take 10 days from now, at which point between Paul and myself, we will try to rationalize, extract the nuggets, summarize them, and do the thinking that I was referring to. So feel free to go back in using the web link and add comments, stuff. They will remain live, as I said, for 10 days. And the last thing is just to reiterate the invitation. I will now stop staring at the screen. That and the link that Sam and Milda put at the very start of this workshop on the chat is where we are trying to, as RTS, understand who is doing what. Lots of initiatives, lots of really good stuff going on. Sometimes it's just hard to make the links and create the required synergies, and sometimes even just making the right contacts. This is why events like this, in person or virtual, are always extremely valuable. Sam and Milda have helped us creating that form so that you can tell us what you're doing in the space that is relevant to the RTS. Thank you very much.
Thank you very much, Luisa. And thank you everyone for contributing. It was great to see everyone participating, and we will share the 3 links when we'll send the event recording as well. So we'll move on to the next speaker now. I would like to invite Rahul Shah from BSI, who will talk about innovation management and how to key to increasing business resilience. Rahul, over to you.
Thank you, Milda, and good afternoon, everybody. What a great presentation by Luisa. So well done, Luisa. That was really great. So please bear with me while I share my slides with you all. Let me know if you can, Milda, once the slides are loaded.
It's coming up. Yeah, we can see them.
Fantastic. So I have 20 minutes, everybody, so I'll be real quick. And
sorry, Rahul, you have 10 minutes.
Oh, sorry, 10 minutes. Sorry. Of course, 10 minutes. As we already saw, from the various presentations today, you could see that there is a lot of advancements in technology, the sensors, the smart maintenance, data driven. So, this message that I wanted to start with is, resonates quite well, that if we look back in time, right from, say, steam engines all the way through to, the assembly lines, the computerization, the electrifications, and in today's world, the integration of digital and physical systems. And Luisa mentioned, and the previous speakers also, about the sensors, the smart maintenance, the data-driven maintenance. So I think what is constant is innovation. We're constantly innovating in terms of the processes, in terms of the business models or products, or the customer experience. So our angle to this as a British Standards Institution is slightly different to today. In today's conversation is more about how to facilitate formalizing innovation for businesses and the industry. And if we look at some of the economies around the world, as you can see on the screen, these are some of the examples, not all of course, that there are government level interventions in terms of formalizing innovation as a key enabler as part of national level development plans. And also if we look at the United Nations Sustainability Development Goals, we can see in particular goal number 9 that how innovation is at the heart of building that resilient infrastructure that we talked about, in the last couple of days, about building that smart, sustainable sort of rail infrastructure, right? So it's very, very important. But if we go down one level, and I think, Luisa, you made reference to HS1, and I would like to draw upon the HS2, the latest the largest infrastructure projects that we are going through in the UK, and they also see innovation as a key enabler as part of the wider goals of sustainability, of resilience, and so forth. And on the left hand side, what we have is some of you might have already been part of that journey with Crossrail, back in almost 10 15 years ago, right, when they started the journey. And they also saw innovation as a key enabler as part of their development. But what they led, and it was a quite pioneering approach in terms of formalizing innovation across the supply chain, across the projects, not just having a product level innovation strategy or a quite pioneering program, Innovate 18, but also they took the supply chain on the journey and enabled them in terms of fostering that innovative culture, fostering that open innovation, right? So, and that was key to the success. And through that experience, many leading firms, and I'm talking about Crossrail on the left-hand side now, through that experience, many supply chain partners realized and recognized the value that the formal innovation management processes can offer to businesses and the wider industry. And now that journey continues through HS2 as well. And some of you might be familiar with HS2's quite innovative program, accelerator, innovation accelerator program, where they encourage SMEs and startups and innovators to be part of the journey as well. So managing innovation at scale and with consistency that is aligned with the strategic objective is very, very important in terms of building resilient infrastructure. And what we've done in the last couple of years, we worked with the industry, the wider built environment industry that included HS2 and other participants, but wider built environment industry. And we captured some of the common business challenges that the businesses are facing and we're facing, in terms of from clients' point of view. If you look at the clients like HS2 or Network Rail or other clients, for them, they want to embrace and adopt that accelerated innovation mindset and culture. But their challenge, one of the challenges, they were facing is formalizing that innovation management program such that they can streamline and efficiently qualify new suppliers as part of the procurement process, for instance. Also, from clients' perspective, they want to foster that culture of open innovation where ideas can be shared openly, and then the supply chain work together in terms of finding innovative solutions. And a key to that is having that common language, having that level playing field, in terms of not only qualifying new suppliers, but also in terms of supporting them in their innovation journey. From suppliers' point of view, when I talk about suppliers, product manufacturers, designers, contractors, subcontractors, and so forth. From their point of view, yes, getting buy-in from the senior management and having alignment with the strategic objectives, but also, in terms of managing intellectual properties and so forth. So these are some of the common challenges that we saw that the businesses were facing in the built environment industry. So what we did is we worked with the industry as the national standards body, with the UK, but also some businesses abroad. And we looked at this international best practice called ISO 56002 as a framework for innovation management. And if you look at this framework, closely, and today we do not have enough time, but that framework is based upon 7 key pillars of any good management system. In this instance, it's innovation management. How do you go about managing innovation, right from the leadership buy-in, strategy, vision, all the way through to planning, support, and executing on your innovation strategy, and then having that continuous performance evaluation and improvement loop. Right. So that standard is, if you haven't heard of it, I would highly recommend that if you want to embed that innovative culture and processes and mindsets as part of your business as well as supply chain, then I would highly recommend to have a look at the standards. It gives you really, really good framework in terms of embedding that innovative culture as part of your business plan and strategy. And so what we did is, as the next step, we sort of developed an independent sort of assurance sort of scheme for businesses to actually validate their innovation, processes, innovation thinking, and innovation framework according to the international best practice ISO 56002. And as part of that, these are some of the key things on the right-hand side. What you see is some of the things that we come and measure based on the outcomes. So I think somebody said in the last sort of presentation during Luisa's presentation that, sometimes people get carried away with shiny piece of technologies and, gadgets, but what actually positive outcomes that technology or innovation is actually delivering is something that we measure as part of that innovation kite mark that businesses were really, really keen when we started developing that. So it's a really outcome-based sort of assurance scheme that validates your innovation strategy, your delivery, your execution that meets, the intended outcomes, either for your business, for your clients, for society. And so just to finish it off, the last slide is overall the way we see having that independent and impartial validation of your innovation program could provide a lot of benefits, some of them which are sort of grouped under these 3 key buckets is in terms of, protecting your own brand, but also enhancing and expanding, your reach globally and to your stakeholders, your shareholders, to your clients, that innovation is not just a small team in our business. Innovation is part of our DNA and part of the culture. And one way to actually demonstrate that commitment to your clients and stakeholders and shareholders is by having some kind of independent validation of it. And this is what at BSI, British Standards Institution, we support businesses with. So I think with that in mind, my time is up. So Milda, thank you very much. And thank you everybody for listening in. Thank you.
Thank you very much, Rahul. And you can see, Rahul, we'll share the slides with all of the attendees as well in the recording, so you'll get the extended pack as well. So thank you very much. We are now moving on to our next speaker, Richard Carr from the University of Huddersfield, who will talk about smart rolling stock maintenance research facilities. So Richard, over to you.
Thank you very much, Milda. Good afternoon, everyone. I'll share my screen. Hopefully Teams will play.
We can see your screen.
Can you see that? Everything okay?
All is
Perfect.
good.
So,
all systems go.
All is good. That's a good start. So, little introduction to myself. My name's Richard Carr. I am the Industry and SME Engagement Manager on the Smart Rolling Stock Maintenance Research Facility project, which is housed within the Institute of Railway Research at the University of Huddersfield. For those of you that don't know the Institute, we are part of Ukraine, and we run the Centre of Excellence in Rolling Stock. We also run the Centre for Innovation in Rail, and we have testing facilities, physical testing facilities, as well as research fellows, people far cleverer than myself. I haven't got time to go into a full presentation on the facility, but you'll be able to contact me after the event if you'd like any more information on what we do in general in rail, but also this particular project. So today I'm going to have a sweeping run through the facility, and in particular why. So what were the key challenges, and picking up on Luisa's presentation, where that fits within the rail technical strategy. And then look at our key work streams in terms of depot workflow and digital twins, robotics and automation, and then very much on today's subject matter, condition monitoring and prognostics. So some of the challenges from a rolling stock maintenance point of view. You can see there that based on the McNulty report, 40% plus of the life cycle cost of maintaining a railway vehicle is in maintenance. The TOCs are on increasing pressure to reduce those costs, and this presentation was put together before the Great British Railways report, and who knows what impact that's going to have. Passenger demand is expected to grow, even despite COVID. We've got a massive fleet, over 14,000 vehicles, and they're maintained across close on 100 depots. And taking into account what we'll see shortly on the rail technical strategy, using smart technologies is definitely seen as a key enabler to improve the efficiency of that maintenance. So the rail technical strategy and the key trains requirement did identify the future requirements and focused on easy to maintain and also safe and rapid inspection and repair. There's an increased emphasis on the use of RCM, also robotics and AI, but including the better use of this. So infrastructure-based RCM, onboard RCM, such as intelligent diagnostic systems, but then intelligent analytical tools. So this is about taking the data and actually doing something with it. And additional benefits from actually monitoring infrastructure on trains. So something like the Siemens Nexus system, and a great example of an SME, Perpetuum, and the systems that they do. So picking up on the rail technical strategy, and honestly, Luisa and I's presentation wasn't produced by the same person at the same time, but we both got red squares and rectangles. So in the reliable and easy to maintain section, you can see the area that's in red, which I've then blown up a little bit. We're picking out their remote condition monitoring. We're picking out their identifying assets that are suitable for robotic and artificial intelligence. We're looking at how that then becomes condition-based inspection. So hopefully we're working on a theme that's certainly been prevalent this afternoon. And then in the data-driven section, again, I've exploded that section in terms of developing new capabilities related to the data, digital twins, advanced AI, and where that will lead us to from the vision for 2025. So taking all that into account, I haven't really got time to talk through this slide in detail, but that's really a practical illustration of how we can take all of this data. That data can be analysed at both a fleet level and a depot level, and then actually deployed through things such as digitally enabled workforce, automated execution with robotics. So we take all that into account and arrive at the Smart Rolling Stock Maintenance Research Facility based up at Huddersfield. It's a £1.8 million project to establish the facility. That's 50% funded from ERDF and 50% match funded. A 3-year project We are 9-10 months into it. The aim is to improve the efficiency and effectiveness of rolling stock maintenance to meet future challenges, and the facilities will include, as of September of this year, when all the construction and setup is complete, maintenance optimization and test facilities, a virtual depot digital twin setup, facilities to process RCM data and develop that data, and augmented reality suite. So in terms of breaking that down into work streams, in terms of depot workflow planning and scheduling, with a view to that becoming virtual depot and a digital twin, we're going to be focusing on optimizing that workflow planning, because we see that as a key element in managing the efficiency of a depot, developing a virtual depot model to support that, looking at the optimal use of resources, helping to achieve train availability, minimizing service disruption, and of course not forgetting minimizing safety risk to the actual employees that work within a depot, looking at layout, and then also being able to quantify the benefits of new tools, new techniques, new machines, new equipment within a depot. That is part of the model that we've started to prepare. You need to speak to somebody far cleverer than me to explain that in detail, but it's taking individual component level information and how that can then begin to feed through into condition-based monitoring, but also into how that fits into the depot activity and scheduling. Robotics and automation, very prevalent in a lot of industries, very much now part of Industry 4.0. We can see it in automotive. We certainly see it becoming something that should be accepted and available in rail. There's a couple of images on the far right of actual robots in use, both under car inspection and also in-car inspection. Some of the tasks that we're looking at: suitability for automation, in terms of inspection using image recognition, surface shape scanning, ultrasonics, torque checks on bolts, axle inspection, oil sampling. In terms of servicing, fueling, sanding, toilet emptying and water, cleaning, as demonstrated by that image earlier of the robot, also front end and under frame cleaning, and the replacement of parts using robots and automation, whether that be brake pads, filters, missing bolts, bearings, pantograph items. So what we're developing, and this will be available from September of this year in the laboratories up at Huddersfield, is a small-scale rail maintenance pit, which will have 2 large KUKA robots either side. Apologies for the quality of this image. We'll also be able to replicate working on the roof by putting a cover over the top of the pit, and the robots can then work at roof height, but also you can see some smaller white robots just in the mist in the middle, working on under chassis and component level stuff. And I said that will be available from September 2021. At the moment, it's a big hole in the ground as construction continues. Supporting depots of the future in terms of looking at increased use of automated and condition monitoring techniques. We're working on the fact of using the data, or the better use of the data. So I think Chris touched on big data. There is no shortage of data coming out of the rail sector at the moment, but we're focusing on better use of that data to develop the most suitable solutions for predictive maintenance, and then use that in combination with support tools like virtual depots and robotics to start to look at the vision of a depot of the future. That just looks through the sort of basis of it as to how we work through a review, industry consultation, break that down into manageable sections, and feeding that out into robotics and virtual depot. So focusing on a little bit more on the data aspect, which today is about, from a prognostic point of view, it's the conversion of the information into a digital form which importantly can support future decisions. It's a key enabler. Previous research, which I just dropped in the phablet chat, shows that RCM could provide up to 30% reduction in train delays, but there's a need for an improvement in the effectiveness of the algorithms, which we are now working on, and also more sophisticated analysis. So an example case study. So this is a live project that we're actually working on the project. It's with a Roscoe. I'm not allowed to say who it is. But what we're looking at is the rolling stock that we're analysing is equipped with onboard diagnostics that are constantly monitoring performance and outputting data, large volumes of operational and condition data, fault codes, environmental variables, etc. What we're drawing on is looking at translating that data into useful information to support maintenance. So instead of it being this is what's happened, we're trying to look at detect and predict what that leads to in terms of a fault analysis process. We're aiming to provide real-time performance-related information. I can see the clock ticking, Milda. Some challenges, significant experience on robotics in manufacturing, but not so much in maintenance. Some condition monitoring, schedule problems, cross-industry data, and how you can get involved very quickly. We're looking for key challenges and opportunities for train maintenance depot operations, suggest some case studies to us that we can investigate collaboratively with our funded researchers, our emphasis on the funded, and assist the project by sharing data with maintenance records and assets. And from a supplier point of view, we're looking for collaboration to demonstrate solutions. I think somebody asked for a skunk works. I hadn't thought of describing ourselves as that, but it sounds good. Looking at sensors and software, models and data management that you can bring to the project, and we can help you develop products or proof of use cases, again, using the assistance of our funded researchers. That's me. It'll be shared as a presentation. I'll be around at the end up till 5 o'clock. Apologies for slightly overrun.
No worries. So you've got a message there from Chris Richard. Have a quick check on the chat. So now we're moving swiftly on to our next speaker, Adam Palm from Product Governance. And Adam, I will be driving your slides. So just let me know when to move them on.
Wonderful, and thank you, Milda. My apologies to everyone that my IT system seems to have failed me today. Oh well, these things happen. Thank you and good afternoon. Thank you for the opportunity to present my company, Product Governance Limited. We provide engineering and management services. Broadly speaking, we're about providing high reliability and low cost design, manufacture, maintenance, supply chain processes and governance, and helping companies to deliver those. We've got experience in rail, automotive, medical, and general engineering. Milda? But specifically around what we're here to discuss today, how does all that relate to data-driven maintenance? Well, from the experience within product governance, we've seen many projects where there's been huge overruns, where lots and lots of data gets produced, but nobody knows what to do with it once they've got it, other than hit the delete key half the time. And lots of very high-cost projects that don't necessarily, or remote condition monitoring projects that don't necessarily deliver on the business objectives that was designed at the beginning. So what I propose, or Product Governance Limited proposes, is more or less a three-step process, which actually nicely meets the discussion that was had this morning. So first one is start with defining your condition-based maintenance requirement first. So you could call that know your asset. So what is the failure history? What is the maintenance history? What are the risk assessments? Now, this works for whether it's retrospect or new design. Certainly with retrospect, it's easy to do failure history, but there are also similar components used in similar other projects, if you could start extracting that history as well. So step one is, as you've already said, know your assets. Step two is create minimum viable RCM solutions. So as with the Agile presentation, minimum viable product or minimum viable solutions to keep it simple. then the third step, of course, and that you could say is collect your data. The third one is digitize installation and maintenance work instructions and spare parts management. And that, of course, is change your business. So we propose that there's 3 steps. And I was actually quite buoyed with the presentation and the case study around the gas turbine delivered by Chris earlier, because I feel that one of the core mistakes that often gets made is that projects tend to run off with a data-driven solution rather than a physics-led solution. There's certainly a place for the data-driven, but if you keep it simple with understanding the underlying physics and drive your data sampling, your taking the data off train through to data centers, through to analytics, driven by what you're actually trying to capture, you get a far better solution. Third slide. So what do we provide? Simply put then, we don't actually, I should say what we don't provide a product, or should I say a tangible physical product. What we do is we provide management and governance of remote condition monitoring and condition-based maintenance projects. We help projects define an end-to-end system, select the right components to achieve the goal, the right supplier management, all the way from sensor, all the way through to digitized work instructions. One of the main things we do by not providing product is that we're technology agnostic. We don't distort the project based on whether a supplier happens to have a particular strength in the project, in the product that they supply, which means they're trying to push the project down one way or another. We're technology agnostic, which means we can provide independent management of the project and governance around the project accordingly, which keeps the project business case focused. So I only had a short amount of time and I'm mindful we run over, so I'll leave it there, other than to perhaps the next slide, Milda, which would give you my contact details should anyone be interested in what we have to offer. Thank you.
Fantastic. Thank you very much, Adam. I will stop sharing the screen now. We have now kind of finished the presentation part of this meeting. If I could invite all of the speakers and all of the attendees who would like to engage in a discussion, please turn your cameras on. Only unmute yourself if you are speaking. We don't want to hear your colleagues chatting in the background. So this is your opportunity now to ask questions of the speakers if you have any, or just chat among yourself. Please do not leave me here on my own. I had enough of that for the past 12 months or 16. I don't know how many months it's been. It's been a long time. So as you can see, we still have lots of speakers there. Well, 2 at the moment still available for your questions. Luisa, I think you're winning as the kind of the most creative presentation with your platform. You're seeing a lot of hearts and likes in the chat. So I will now just, if you have any questions, turn your camera on and start talking, or raise your hand, whatever is comfortable for you. If you will not do that yourself, I will start poking around in the attendee list, see who is there, if I see any familiar names, or maybe pick somebody out from the chat. So Luisa, I don't know whether you had a more chance to look at the comments that was being submitted in your tool. Is there anything else that came up that's surprising, maybe?
No, I don't think that there is anything completely completely surprising. But it's very interesting to reflect on what people actually focus on and which bit they pick, because no matter how much we tried in the RTS work, we always reach to a very, very small population. There are what I call the usual friends and suspects and family, and they are well known, and we kind of are best friend anyhow, and really close colleagues, and then you expand the circle a lot, but you still, you know, reach the cross industry groups. You still reach somehow a very small population. So it's nice to see what a different group picks and focuses on, and so that would be my reflection. The time was what it was, so you heard me lots talking, and I could see some typing, so that worked. I think that is really important to define, kind of to try to work on the to be, because there are lots of opportunities, plenty, and the challenge in my mind is as I said, to build on small and successfully, because otherwise I think that we have seen some journey where, being a Rosco or an OEM, they tried too big too quick maybe, and where they are now is maybe losing on other opportunities, because that just burns as a memory of things not going well.
Okay, yeah. Rahul, it was very interesting to hear about your innovation kite mark product. Is there anybody in the railway industry that's leading the way with your product, or share us your gossip?
Yeah, thanks for giving us an opportunity to share what we're doing. So yeah, I mean, I mentioned HS2, so we are working quite closely. In fact, HS2 was heavily involved in developing the whole assurance, the certification, kite mark, call it, process, because it was them who actually were very keen to provide that level playing field to startups all the way through to SMEs, medium, large, and the large enterprises, right? Because a lot of the times, I mean, they have thousands and thousands of suppliers on board, right? And one of their challenges was to actually, as I mentioned, was procurement and qualifying new suppliers, because most of the time people talk the talk, write the descriptions that, oh, we have fantastic smart sensor based technology, drone, this, that, and we are really innovative company. But as a client, as HS2, how can we validate that statement? How can we make sure that they have the scalable, the consistent innovation culture and mindset in the business, and they will bring that to our project? So I think it was led by them. And then so we see this whole innovation management process. And Luisa, you just mentioned as well in your comment that a company, I can't remember now the name of the company, but they tried to go too big too quick. And it's just having that managing innovation and having the processes and framework in place so that you have the check-in points, right, that is aligned with your strategic intent, strategic objectives, resources, and everything. So yeah, we have HS2. We work with HS2 suppliers. They put forward 3 of their startups from their innovation accelerator program as well to go through these kite marks. So they are startups like 3-year-old, 5-year-old kind of startups. So we are taking them through the journey as well. And for those 3 startups, it was like an eye opener, because all they thought was, as innovators, is we want to innovate. Like the technology, the drone, the sensors, these, but they never thought about approaching it strategically as innovation as a process. So yeah, we are HS2. We are talking to and we I don't know if the members know I3P, Industry Innovation Platform, I3P, Infrastructure Industry Innovation Platform, and we work with them as well as part of the development, and we delivered same session to their member group as well. So it's a slowly, we only launched that scheme in December, but we are seeing, some good uptake in the UK construction industry mainly. And today was an opportunity to actually share that with the rail industry partners as well.
Okay.
Thank you.
Thank you very much. I would like to give an opportunity for our attendees who have been all 4 days and listened to our speakers patiently without having that opportunity to chime in. So please do switch on your camera. You can do that anytime. I have some questions coming in from my colleagues as well that I will share. There's Sam. He's been the kind of the brains of operations of the whole 2 days.
That's flattery there. I put my camera on because I had a quick question for Chris, actually, if I could. So it seems, Chris, as though you've got a window across aero, industrial gas turbines and rail. And I'm interested how the appetite, perhaps you could call it that, the appetite for RCM varies across those industries. And if there is a variation, do you think that's because, we're assuming rail's a little bit behind in this field, given the examples you've given? Is it because they've got more forward-thinking accountants? Is it private sector competition? I don't know.
So a bit of it's research, I think. So if you think about what happens in defence circles and what happens in complex warships, you think about research that goes on with DSTL being primary research organisations, UK government there. They spend hundreds and hundreds of millions. I think DSTL's budget is 600 or 700 million quid a year, doing things to prove principles. You think about what Civil Aero have done. They had a program on autonomy of air platforms that I was involved in eight years ago now, called the Australia 2 program, and they stand up big demonstrators perhaps a bit quicker than you sometimes see other industries doing. And I think rail's somewhere in the middle ground there, because you got obviously Luisa, RSSB are pushing all that research into industry. I think rail are much better than some other sectors of joining up end customer need with research. You often find some and defence fall for this occasionally, but the topics of research don't align with end user need. I see far less of that in the rail sector. I think it's a much more joined up picture because RSSB and others are there to join those dots, and it works quite well. Around the kind of condition-based maintenance and reactive maintenance and all the rest of it, ultimately the commercial landscape drives it all. So the early adopters are nervous. If I looked at so I look after our Teesside office in Middlesbrough in the northeast. I look at the process cluster and the chemical industry that sits on Teesside. Not one person there wants to be the first adopter of life extension prediction models. They're quite happy to be the second one, but their processes, you take what companies like Savic do in that, they're operating at massive temperatures, massive pressures to do the things they do. And if they get it wrong, it could be the difference between being in business and not being in business for big organizations like that. And they don't want to be those early adopters. And as a result, the industry isn't moving into that space as quickly as I can see the opportunities for them to do so. But it's for the right reasons. Rail, I think, have got the opportunity to do it. I think it's already happening in some places. You look at some of the instrumentation you get on freight wagons now. Most of my stuff in the last 12 months has been around the freight sector. The repair work I talked about this morning, Luisa, for RSSB, I presented that earlier, but it's been freight focused. And you look at what people like VTG are doing, and they've got their black box data on all their wagons where they're starting to record positional information. How can it's things like, how do you take that data and do more with it? So it's not just about knowing where your wagons are, it's knowing where your wagons are, inferring some context for what they've been doing, i.e. the routes they've been operating, looking at the maintenance history of what's gone on. What can you do with that data? And in answer, I'll shut up in a minute, Sam, but in answer to your question in the chat earlier, sometimes there is nothing written down, and people view that as an obstacle. There's no written down or no information about where failures have happened and what it means. But actually, you don't always need something written down. We've done some stuff for a UK warship, a Type 23 frigate specifically, where they didn't have much maintenance data about failures, but you've got sailors at sea, you are there replacing these things. They know exactly how often they fail, they know exactly when it goes wrong, and they know exactly why. And not a lot of it is easily accessible and written down, but you can start with user opinion. And actually you can do quite a lot of reactive maintenance planning just on people's knowledge. You don't need necessarily any data. Well, that is data, but you know what I mean? You don't need any ones and noughts. You can actually just take spoken word as a good starting point. I've strayed slightly from your question, but yeah, I think the opportunity's there in rail. I think it could be realised. I'd see some demonstrator projects, a bit like Richard was talking about, where some facilities to do some demonstrated skunk work stuff come out of Louisa. Good place to start.
Well, talking about Richard, what are the opportunities for, how it would work for SMEs to come and play with your robots? Do they need, how the funding works and how the intellectual property protection works? How to get involved?
Good question. I'll take the last part first. We're we're pretty open because we're a research facility, but clearly IP and protection of that for the future from an SME point of view, I fully understand why that would be quite important to them, because that's where I come from as a previous business owner. So we're happy to have conversations from a supply chain point of view around not just anything that the supply chain think might fit the project. Just come and talk to us and we'll decide between us if it will fit the project. It might not fit the project, but it might fit the capabilities of the Rail Research Institution at Huddersfield, because the smart rolling stock is just one thing. And because it's part funded, we have to tick certain boxes, but the Institute has got much wider capabilities. I think that's the same for industry. If industry has a challenge, but it's not quite sure if it fits, just ask, and it's kind of my job to be the front door, talk to people, but my job is not to close the door. So my job is to talk and understand, and hopefully with my background, particularly in the depot environment, I can understand most of the discussion and then filter it through to the relevant people. One of my colleagues on the project is actually he was on the meeting. If Adam's still there, yes, he is. So we're very open. It's not early days in a sense. Our research fellows have been in post since December, hence why we are working on projects. So project I half touched on because I was running out of time. We're working on the virtual twin and starting to develop that with industry partners. And obviously we're working on the automation and robotics stuff. The robots are ordered. They will physically be going into the pit, all things being equal, in August, and be up and running and ready to start being used in anger from September onwards. And we're quite open to have discussions with anybody, and then we'll hopefully jointly decide. And ideally, I think the word collaboration is key, because that's what we should be doing as a university, is collaborate with industry and the supply chain to come up with solutions that fall back into what Luisa and I both touched on in terms of the rail technical strategy and why that is the way to go forward for 2025 and beyond.
Wow, you can be sure, Richard, that Sam and I just made a mental note on these timelines, and we'll be we'll be knocking on your door saying, "Can we host the next Unlocking Innovation and see how the robots work?"
Absolutely, we'd love to. Hopefully by September onwards, the university will have relaxed its own high-level COVID restrictions, and we'll be able to meet in person.
Fantastic. So if there are no more questions, I think I will release you a few minutes earlier. So just allow me to thank the speakers and the audience, and obviously my colleagues as well, just working together. And hopefully we will not have to do virtual events ever again. I mean, it's very convenient because we have the record of them. And as I said, we are posting them on our YouTube channel. And we'll share the recordings of this week, next week. We'll share the presentations as well. So, but actually having to see you and have a coffee with you and have that little chat would be so much better. So thank you again, everyone. And hopefully